Okay, so hello, I am Paweł Marks, as I was introduced. Thank you for that. And I work as Kotlin tooling architect in Virtus Lab in Krakow. I am also leading team of developers that is re-implementing or redesigning Dokka from the scratch. And this will be the topic of my today's talk. So the new Dokka designed for fearless creativity, or why we re-implemented documentation engine from the scratch, or how to be flexible without worries. So yeah, today I want to talk about documentation. And documentation is, I think, the most transparent part of software development because you usually don't care about it that much. It just works, or if it doesn't. So basically, if documentation works, you don't have to think about it. You even don't think that there are people that are maintaining it, that implemented your documentation engine, or are fixing back in that. So take an example of Javadoc. It is a great documentation engine because it just works. It is old as Java itself. You just take some Java sources, run javadoc command, and you get something like this. So fully fledged documentation. And it was naturally to expect from Kotlin to have its own documentation engine. So even before Kotlin 1.0, the guys at JetBrains started working on a documentation engine for Kotlin called Dokka. So Dokka started as kind of simple project. It needed to just do what Javadoc was doing, but for Kotlin. But it was already more complicated than Javadoc because Kotlin is apparently much more complicated language than Java. Its analysis is much harder because it has much more constructs. So even providing the basic features such as Javadoc was much harder for Kotlin. And guys from Dokka not only wanted to provide some simple documentation like that, but also wanted to have more features, and people are really eager to request new features. So it was natural that Dokka was generating some HTML format, but some folks wanted to have one beautiful pre-designed HTML format, and some of them wanted to customize it with its own style sheet and own twists. Also, some people wanted to have Markdown documentation for their code base. So, for example, they can put that on GitHub pages or some other hosting services. Also, many companies requires that all code that can be run from Java and, or broadly speaking, is targeting JVM should have Javadoc, as Javadoc is standard for JVM documentation. So it was expected for Dokka to generate Javadocs. Also, many projects in Kotlin have mixed sources, so they contain both Java sources and Kotlin sources. So it was quite natural that Dokka will be able to parse Java code and generate the same documentation as for Kotlin. Also, some frameworks and environment heavily rely on some synthetic symbols. And by synthetic symbols, I mean function and properties that you do not define yourself, but are generated by compiler from or other tool from some XML files or other stuff like resources on Android, for example. Some people wanted to have code samples in their documentation, but not only to view code samples, but to have ability to type check them, possibly to run them, or even for users looking at the documentation to edit these code samples to check if something other will also work. Okay, some folks are working with REST APIs, so they wanted the documentation of their REST endpoints to be somehow linked to documentation of code in controller that is running those REST endpoints. And some people expected that if you can just use search with auto-completion in IntelliJ, it's only natural that this feature will be also available in your documentation. So they wanted Dokka to have advanced search for symbols. Also, some people wanted to have ability to publish their documentation in such a way that you can side by side compare documentation of some symbols and source code for them. So they wanted integration with GitHub and other source code hosting platforms. And last but not the least, Kotlin is multi-platform language. So many folks wanted that fact to be reflected in documentation. So for example, when you're developing using some multi-platform Kotlin library, using it only on Kotlin JS, you wanted to see at a glance what methods are available on JS, and possibly you wanted to filter out all methods from other platforms. So you are not interested in methods that are only available on Kotlin for JVM. And developers of Dokka solved most of this problem, provided most of these features. Some of them was solved by introduction of formatter concept into Dokka. So basically you can have the rear end of Dokka, something that takes Dokka model and dump it into disk, into files, can be swapped for something else. So for example, you have different formatters for HTML, different for different flavors or Markdown, but as you can see, only some small fraction of feature can be delivered that way. So Dokka needed something more. So some of these features were hard-coded into Dokka. For example, javadoc was so basic feature and so requested that it was kind of natural in that moment that it should be part of base Dokka. So you just switch with configuration Dokka to work in javadoc mode, and it generates javadoc instead of all other documentation. Also, parsing Java code was also hard-coded, and in version 0.10 of Dokka, they added platform makers to that. But still, there are multiple features that are not implemented by that. And some of this feature really applies to a small fraction of the user base, but this fraction of user base can be really, really important. So developers of Dokka came up with quite simple solutions called binary patching. It was the first form of pluggability in Dokka, but it was really not great. It's work on principle that you take distribution of Dokka, unpack it, then substitute some class with your OR version of this class, pack it again together, and then redistribute that. And this allows to implement few important features, but it was really, really not maintainable. First of all, I've never heard about anyone who managed to use more than one plugin in such a way, because actually you have absolutely no way to cooperate between different plugins. You are lucky, or it just doesn't work. Dokka model becoming more and more dissolved. With time, with the new hard-coded features, model needs to hold more and more data and was becoming more and more amorphous. And last of these problems were complete lack of guarantees. When you are developing or plugin for Dokka in some other way, extending Dokka, you cannot be sure when and where some data you want will be available. So sadly, it was a fun project, but it was no longer maintainable. So we at Virtus Lab gained the green light from JetBrains to re-implement Dokka from the scratch. And our goal was to make it such pluggable as it is possible. And of course, I show you screens from javadoc and from old Dokka, so I should show you how new Dokka looks right now. This is not mockup. This is not wireframe. This is something that is aesthetically generated with our snapshot branch that I think is slightly over 2 weeks old right now. There are a few rough edges. I can see right now a few things are missing here and there. Some of them are even fixed right now on dev branch, but it's quite better. It's more readable, I think, and will be even better at release. And we've already implemented many requested features. They are available out of the box. For example, search with auto-completion. You can use it right now in Dokka. Okay, but the topic of today's talk is about pluggability. So I should show you how plugins work. And to understand the best how plugins work, I think we should create one for us. So as I said, plugins are solutions. And to have solution, we first need to have a problem. So let's make up some problem. Let's imagine you are working for some company providing some mathematical libraries, and you want it to look professional, and you wanted your documentation to look professional. And what is more professional than maths equations in your documentation? So you found that there exists some syntax called mathjax, which allows you to write mathematical equation, really complex one, just in plain text, and then include some JS library to your final page, and it is rendered. But of course, this feature is not provided by Dokka out of the box, because we focus on other thing. We cannot just support every possible format of documentation extension users can imagine. This is why we have pluggability, so the users can implement that themselves. So in this example, the function, its name, its body is completely irrelevant. What is important is this kdoc comment above it, and actually two things inside of it. The first one being this uses mathjax annotation-like thingy. It is called doctag. And it is instruction for documentation engine that to render this comment, it should use mathjax. And there are some equation written in mathjax syntax. So when you run Dokka on that, you gain something like that. So basically, all of these equations are in plain text, nothing is rendered. That was expected. But we wanted to change that, writing plugin ourselves. So the solution. To create plugin, we just need to create plain Gradle project. So here it is structure. This is really ordinary Gradle projects, but I want you to point you to three files, which are important here. The first one being build Gradle, quite ordinary Kotlin stuff, but it has this one dependency. So compile only dependency on Dokka core. You want to use in your plugin symbols from Dokka core because they are required to actually write a plugin. But you want your dependency to be compile only, to not inflate dependencies without the need, because Dokka core will be already provided in Dokka and your plugin will be only run in context of Dokka. So compile only is okay. And probably if you're watching recording of this talk in the future, you will no longer see stuff like Dokka core 0.11.0/snapshot, but actually you will have Dokka core 1 point something published on Maven local. Okay, the second thing here is slightly more abstract. It is service definition, because we somehow must have some entry point for every plugin in Dokka. So we decided to use the oldest and I think the simplest possible mechanism for that, which is JVM service loaders. And for them to work, you need to, in your special directory called meta-inf services, create file that has name that is the name of the service. So in our case, it is fully qualified name of Dokka plugin class. And inside of that, you've got just that. So just fully qualified name of the class that will be entry point to your plugin. In our case, it is just org example mathjax plugin. Okay, so let's take a look at this class. Really simple Kotlin class. The only notable thing here is that we need to extend Dokka plugin abstract base class. Because all Dokka plugins are implementing Dokka plugin base class. So to see what we should put inside of that, let me tell you what exactly are plugins. So we will see what we wanted to achieve with our plugin. So I think a formal definition of plugin is something like that it is piece of software that is changing behavior of different piece of software that is developed and distributed separately from that and can be installed and uninstalled from this host software. But for our practical purposes, let's just focus that plugins are sets of extension and extension points. What are extension and extension points? I like to think about them in an analogy to a children's toy. I think it's called sorter in English. It's a box. On the one wall of that, you've got holes in different shapes, and you've got blocks, and each blocks only fits into one hole. So these holes can be thought of as extension points, and these blocks are analogous to extensions. So basically, extension point is the fact that some framework or other plugin is specifying that they need something to be implemented. They require some capability for other plugins to implement, and extensions are implementation of these capabilities that can be put like a blocks in this holes, so extension can be pulled inside of extension points. Okay, so now I want to show you where these extension points are in Dokka. And to show you that, I wanted to first show you the model of Dokka, or actually the models, because new Dokka is all about models transformations. So let me start at the beginning of our pipeline. Here we have something that is called input. It is generalization of any sources. So Dokka out of the box support Kotlin sources, Java sources, but you can put here with your plugin everything. For example, you can read some input from the database. You can send some request on some REST API. It doesn't matter what it is. You only have to provide some way of parsing it into Dokka. Then inputs are transformed into documentables. Documentables are model describing how compiler sees source code. So every non-private symbol in your Kotlin codebase is represented in documentables tree, and these symbols are arranged in a tree how they are logically understood by the compiler. So it doesn't matter where given function is in file, or if two functions from the same package are in different files, they are part of the same package, so they are children of the package. And every symbol has its own documentable. Then we are no longer about how compilers see stuff, and now we are about how the end users will see our documentation. So we'll have something called pages model. And you have different kind of pages. As a page, you can understood basically something that user will see at once when he will look at screen reading some documentation. So for example, module index can be a page, package index can be page, documentation of some class or documentation of some function can be also flowed as pages. This is what we call content pages, and they are also what we call technical pages. So for example, search page that gives you search functionality. And inside of these pages, there is some abstract representation of what users should see. So you have some tags. They are quite similar to Markdown or HTML tags. So you have some headers, block groups, signatures, etc. And basically editing this page, you can specify exactly what will be rendered to end user. And at the end, we've got our outputs. This is anything that Dokka can produce, and you can make with plugins that Dokka can produce nearly everything. Out of the box, we support HTML and few different flavors of Markdown, but as with inputs, you can put here actually everything. For example, you can just dump your pages into some database and then serve them using some dynamic server. Okay, so where are the extension points? They are on this diagram as these blue arrows, at least some of them. Some that we called core extension are just transformations from one model into another or from one model into itself. So, for example, Dokka needs a way to transform pages into output. So it specifies extension points called renderer. So it is information for plugin that Dokka is expecting plugins to give it some kind of renderer. There is also documentable to page translator. So something that Dokka will be using to take documentables and produce pages based on that. And some of this extension point, as you can see, are reflexive transformation of models. So for example, documentable transformers are taking documentables, changing them slightly, rearranging, adding new stuff, removing some stuff, filtering. And then the new documentable model returned by one of these transformer is then processed down the line by other documentable transformers or by further steps in Dokka pipeline. And every Dokka run is just a set of extensions that are extending these extension points. Of course, you don't have to specify all of them. Dokka has something that is called base plugin that is a really big set of default extensions and defaults and reasonable defaults for different situations. So most of the time you just need to run Dokka without including any plugins or specifying any extension points. But let's see some example of configuration of Dokka of instantiated extensions. So basically, in this run, we want to parse both Java and Kotlin sources. So we installed two default source to documentable translators. Also, we want to add some synthetic functions. So we added some plugin that is adding synthetic function generator extension. It's made up extension, but it may look like that. Then we are using default translator to transform documentable into pages, and to our page transformer. One is merging function with the same name, and the other is generating navigation for our documentation. And we then want to render it just to be plain HTML. But let's now get back to our main goal. Our main goal is to write our first plugin that will provide support for mavjax. So what of these extension points should we use? We wanted to transform page, really, because we wanted to search if any element documented on this page contains use mavjax annotation or doc tag, and then add to that page some JS library that will handle stuff. So the answer is page transformer. We want our plugin to just add new page transformer. So to create extension, we just need to create new property inside of Dokka plugin. There are no any abstract method that it should overload. We are just adding property, and we are using extending delegate for that. And this extending delegate inside of this block provides us with what we call extension DSL. And the most basic simple form, this extension DSL looks something like this. So we are specifying that we want to extend one of core extensions called page transformer with something that we call mavjax transformer. And mavjax transformer is really simple transformer. It doesn't need to hold any state. It doesn't need to it doesn't require any outside knowledge about the word, any context, so we can just make it from static object. So we've done something like this. You may wonder why there are no any methods that allows us to initialize extensions or just list them. Why we have to use this strange construct that is some property delegate with some special DSL. I will explain to that, but later, in a few minutes. Let's just for now put a pin on that and focus on mavjax transformer. Right now, this code won't compile because our extension points are type safe. So mavjax transformer needs to implement a type of this extension point. So it needs to be page transformer. So we've made mavjax transformer implement page transformer. It's really simple interface. It only has one method. It's take input of type root page node and return another root page node. Root page node are, as the name suggests, root of page tree-like structure, so they can be thought of as passing entire trees of pages. Okay, so let us take a quick look at content page. This is the most basic interface for pages that is implemented by every package, module, class, function, property, etc. Page. And it has two interesting properties for us. The first one is documentable. This is property that allows us to access what exactly documentable, what Kotlin symbol is documented on given page. So we can just check its documentation and check if it contains doc tag interesting for us. And it has something called embedded resources. So it is list of URLs of style sheets and or JS script files that are included on that page. So here we have our two properties, and we want to use them to implement our mavjax transformer. So you probably wonder why they are val, why they are not list, not mutable list. But let's for now put a pin on that. I will get back to this in a few minutes. So our implementation of mavjax transformer, we added two constants, one with text of annotation we are looking for, and the other with URL of this library. And we are implementing this by using something that is called transfer content pages tree on input. This is method that is analogous to map on the list. So basically we are taking all content pages from given tree, applying some modifications to them and returning them with the same structure, but slightly modified. So inside of block of transfer content pages nodes tree, we are actually providing pages that are the same, but have new embedded resources that are old embedded resources, plus if given page is needing mavjax, we add our resource in form of URL address, or we are adding nothing. So we are returning original embedded resources. And let's follow this method so I can show you how our extension property is needing mavjax looks like. We are just taking documentable from this page, content page. We are doing some flat mapping to get all doc tags in its documentation, and we are searching if any of its doc tags have name the same as our notation, so uses mavjax. So that's all. Entire code of this plugin, minus the imports, of course, can fit on single screen. And this is all that we need. So now let's load some plugin. To run Dokka with our plugin, we need to add special kind of dependency to the project on which we are running Dokka. This dependency is not of type implementation, compile, API, or something like that, but of special type Dokka plugin, or I should more precisely say that we should add dependency to the configuration called Dokka plugin. And this configuration support any kind of Gradle dependency notation. So for example, if we put our plugin as a module in our project, we can just use project notation like that. Or if we publish it to Maven local, or even better to Maven central, because we wanted more people than us to use it, we can use standard Maven coordinates like that. And when we run Dokka, we will see that the first line of its log is showing right now that there is not one Dokka-based plugin loaded, but actually two of them. And below that, you will see some very long list of extension and extension points loaded. And on that, you will see your own extension loaded. So mavjax transformer. And when you run it, voila, you've got something like that. All equations are rendered. So our JS file was added to the places where it was needed, and it's worked. And this is not made up example. We are actually using mavjax to test our plugin API, and you can find code of this plugin on our repository. Check if it works. Okay, so it seems like right now that plugin just works. Probably I could end my talk here. I could say in conclusion something like that plugins are like furnitures you can assemble yourself, and there are no problems, and everything is beautiful and wonderful. But probably you may wonder that why our current approach to pluggability is better than what was old Dokka doing. Of course, extension and extension point are slightly more organized, but we probably will run also in the same problems that old Dokka ran into. So inability to cooperate between plugins or diffusion of model. But as a good furniture manufacturer provides good instructions how to assemble these furnitures, we are also providing some manuals, some instructions, but our instructions are really special because they are not, you actually have to apply them in practice, because in many cases, there is no other way to actually write plugin than to use our guarantees. And the guarantees is the word that we use to describe them. And there are a few of them. You've seen at least two already. And let me show you a few examples of our guarantees. So first of them is that we have type-safe plugin dependencies. This is the reason why we need to declare all our extension points and all our extensions as a properties. We want Kotlin compiler, because Kotlin is compiled language, so let's leverage that. We want Kotlin compiler to actually understand that they are symbols, that they have its own type, so it can check many things for us. For example, we cannot apply extension of different type to extension points that have some specified type. So for example, we cannot specify documentable transformer as a page transformer. Also, here you can see some slightly more advanced example of extension DSL. We've got order blocks that are specifying dependencies between extensions. So here we are specifying that our transformer is running after generate synthetic function from some synthetic plugin. And both synthetic plugin and generate synthetic functions are not just identifiers, are not just strings. They are symbols of Kotlin. They need to be available during compile time. They need to be type checked. So this allows us to ensure that if you want to depend on some other extensions, you actually need to have it as your dependency. So for example, creating Gradle project, you need to add a dependency to synthetic plugin to have access to its symbols. And if you are not doing something crazy, because you of course can do something crazy with your class path, if you have properly defined dependency for synthetic plugin, it is also assured that you will have those plugins in your runtime class path, and Dokka will load it. So if you're in normal circumstances, if your code compiles, it also assures that when it will be run, these plugins that you depend on will be also downloaded and will be applied to your Dokka run. Here you can also see second example when we are extending some extension point called renderer from some helpers plugin. And also it is symbol, both plugin and it is type, and property specifying this extension point are symbols of Kotlin. So you need to have them on class path, you need to have them as dependency, and this not in very normal circumstances mean that they are your dependency also in runtime. So you cannot extend, you are physically not able to extend something that you are not included into your processing. Okay, the second guarantee you've also seen is about immutability. In Dokka core, in Dokka base plugin, there are no variables. Every possible value is immutable because we realize that lots of problems in old Dokka, lots of subtle bugs, and lots of difficulties in debugging comes from the fact that things are mutable and you can change them, and other plugins can change them whenever you want it. All Dokka structures are persistent data structures, so it actually means that when you want to change something, you don't need to copy the whole structure. You just copy some element you are actively modifying, and all others elements are preserved, are used, references to them are used, and we are applying this optimization really, really aggressively. For example, if in Mavjax plugin example, you didn't see that, but nothing will be copied if you don't include this Mavjax tag. So we are optimizing it really, really aggressively, and this allows us to have not so big memory and performance footprint. thanks to immutability. And also, we can easier make multiple things asynchronous. For example, all of our rendering is completely asynchronous and completely concurrent. Also, the similar guarantee is about contextlessness. We say that element is contextless if it has no knowledge about its surrounding. It only cares about its own state and about list of its children, because it's tree-like structure. So we cannot break anything with moving these elements around. Practically all of Dokka model elements are contextless. So let's see example of pages. We have some pages tree with function documentation, and this function documentation then after some transformation is moved to some other place inside this model, from blue package index under some purple class index. But this is the same function documentation page. Nothing has changed inside of function documentation. We don't need to swap any reference to parent or anything like that. This is the same object and everything is okay. You cannot break any contract, and you cannot, thanks to contextlessness, you cannot introduce any invalid state by only moving elements around. So you can do it freely. And the last of our guarantees I wanted to show you today is about identifiability. We say that things are identifiable because they have quite unique and quite clever ID. We call it DRI, so Dokka Resource Identifier. It was kind of tricky to get it right, but basically it works such as if two symbols are in all possible contexts indistinguishable for the compiler, they have the same DRI, and every other objects have different DRI. So basically, if there's one single context in which you can distinguish two symbols, they need to have different DRIs. And absolutely everything inside of Dokka model has one or more of these identifiers. It is quite useful because, for example, you have some documentable model and you have this property marked here in red. And after many, many transformations, you end up with, and translation, you end up with one page for all properties documentation, and your property is only a small fragment of this page. But even this small fragment also contains some DRI, and you can take this DRI and link it to original property and vice versa. So nothing is lost. Okay, so I think our time is slowly running out, and I can talk about Dokka and about pluggability for hours, because here I only scratched the surface. There is so much more I can tell you about. But let's jump to the conclusion. From today's talk, I wanted you to remember 3 non-related things. First of them is the new Dokka is coming out soon. I cannot give you exact date because release of Dokka is part of much larger Kotlin release cycle. So there are multiple factors that are outside of my knowledge and outside of my influence. But I can assure you, we are on the final stretch with Dokka, and it will be ready soon for you to test out. And I can also, as a second conclusion, assure you that new Dokka will be better looking, more consistent, and flexible than ever. And as a last thought of today's presentation, I want to shortly talk about one of our design principles when we are re-implementing or redesigning Dokka, that strong guarantees are key to extensibility. It seems like it is counterintuitive because guarantees can, like immutability, contextlessness, can be thought of as restrictions. But if you have framework, and we hope that Dokka is such a framework that makes you really easy to work obeying these guarantees, it makes it really hard for you to not obey them, they actually allows you to don't worry about anything. You can be just creative as you want and don't need for you to worry that you will break anything for any other plugin. So, thank you. Hope you will try new Dokka soon, and let's be creative. Okay, so I think I've got a few minutes left. So I will jump to, are there any questions? Okay, I probably don't see any, or I need to refresh my page. Okay. Oh, okay, I can. Okay, sorry for small technical problems. And okay, but I think I cannot see any questions here on chat. So let me check if there are some on Slack. Okay, so I probably don't see anything. So if you have something, I will be available at Kotliners launch Slack channel. So ping me there. Thank you and see ya.